Alrighty, so continuing Calculus 2 notes. Intermediate value theorem. Okay? Intermediate value theorem. Let f be a function that is continuous on a closed interval. Now, class, what is closed?
Like from it's given a specific domain.
Okay, what's a closed interval though? Go ahead, James, show them.
Yeah, the brackets.
Thank you, that's what we're looking for. Brackets. So is it including the endpoints?
Yeah.
There we go. That's what we're looking for. So it's including the endpoints there, right?
Yeah.
Okay. So, and right here it says f of A is not equal to f of B. So what does that mean? What does that mean if f of A is not equal to f of B?
It's not like a point. Is it two different points?
So I'm going to go back to this one right here. So see this right here? So if this is my A and this is my B, they're not the same. They can't be the same number. Okay? For the intermediate value to work, I can't have these be the same number. So it's either an incline or a decline. So you're either climbing a mountain or going down a mountain. That's what this is for. Okay? N is any number in between those two right there. N is going to be any number in between there. Then there is at least one number, C, in the open interval. So now it's saying over the open interval, what does that mean?
Oh, dude, I'll pull a Jimmy.
Okay, very good. Very good. But what is it actually saying? Because right now we stated at the beginning on an interval that's closed, but now on an open interval.
It can't be A or B. C can't
Thank
be on
you.
A or B.
It cannot include A or B. Right? It cannot include the endpoints. That's the point we're trying to get at. It cannot include the endpoints here. Okay? So on an open interval A to B, for which f of C is equal to n. So it's going to be some value in between here and here. Okay? So, to get a better idea of this result, suppose you climb a mountain starting at an elevation of 2,000 meters. That's where we are here. Okay, ending at an elevation of 5,000 meters. Okay, there's my A, there's my B. No matter how many ups and downs that you take as you climb, sometime your altitude must be here. Somewhere, some way, okay, has to be there. Or any other number between there and there. So, I heard it as a joke one time, and it actually, it made so much sense. It started off with the chicken crossing the road. Okay, it's like somehow, so it was a chicken cross the road. So your chicken starts on one side and it ends on the other. Somewhere in between, it has to actually cross the road, right? So you could walk up and down the side of the road till you could actually find like a good spot. So you guys ever like cross the road? Or do you go all the way to the crosswalk?
No.
No, yeah, I've seen you guys all the time. Like jumping over here at the light rail right in front of me. Okay, so somewhere in between, so as you're like finding, you're eventually going to have to get all the way across there, right?
Yes.
So you're going to cross somewhere here. That's what the intermediate value theorem, that it is going to be somewhere in there. Okay, we're going to find it in there. So when we're doing this, you're going to have some equations for this. Use intermediate value theorem to show that has a 0 between 1 and 2. So what does this mean? Give this to me in math terms. Thinking about that last one, that last problem that we did. What are my math terms on this one?
Just the exact definition of the intermediate value.
Okay, start it. Use A, B's, and the function that I gave you.
Let f be a function that is continuous on a closed interval.
Okay, so yes.
So 1, 2, closed interval.
1, 2, thank you. That's what I'm looking for. 1, 2, closed interval.
And f of 1 must not equal f of 2. So
Okay, so f of 1 is not equal to f of 2. Okay, so that's my intermediate value theorem. That somewhere it's going to be in there, and they're not going to have the same endpoints, right? Okay.
And then find the values of both of them, and if n is a number between them, which I believe the values are -1 and 8, so n, which is 0, is between -1 and 8. Therefore, there must exist a number or a value c that equals 0.
Okay, so a couple things we could do here. A couple things we could do. We know it's going to end there and there, right? Let's check those endpoints. Let's check those endpoints here. Okay, we're proving this is going to work, so check the endpoints. So to check the endpoint, what should I do?
Plug it in.
Plug it in. Okay, let's start with f of 1. What is f of 1 going to be? What is it? So let me see what I got here. So this is going to be 1, 1, minus 1, minus 2.
-1. I think it's yeah, -1.
Okay, equals -1. There we go.
8 -2.
Okay, so this next one. Okay, so this is going to be what? 8, 4, minus 2, right?
8.
You get 8. So are these equal?
No.
No.
No, they're not. Okay, so that's very good. So my intermediate value theorem says what?
Well, because there's a negative, right, and then a positive in between there has to be a 0. It has to cross that road.
If this is continuous,
Okay. Yeah, if it's continuous on this closed interval, that value c, in this case it's going to be a 0, has to exist in between -1 and 8.
yeah. Now, so we've shown that the endpoints there exists, so there's going to be a 0 somewhere in between there. Okay. Do you want to find the 0?
No, I just we know it's there.
It's somewhere between.
It's somewhere.
It's somewhere in between there.
We can only be off by one number if we guess any number between that.
So somewhere in between there, it's going to be equal to 0. So basically, it's asking for my f of x to equal 0, right? And what degree is this polynomial? Third degree, right? So if it is a third degree, what does that mean about my function? How many zeros can I have?
3.
I could have 3 zeros, right? A parabola, how many zeros would I have? 2. Because if I'm thinking about it, a parabola would be like a x plus 1 and a x minus 2, right? That gives me an x squared, doesn't it? So each one of those is going to give me a 0, isn't it? If I'm using the 0 product rule, equals 0. The blue on the thing, there we go. Okay, 0 product rule is going to tell me that there's going to be some zeros in there. Okay, if it's done right, 0 product rule, it will work. Okay, so that's a square, that's a parabola. And then a cube right there. So that's going to give me a third degree. So that means I'm going to have up to 3 zeros. Okay, I can only have 3 zeros there. Is it possible to have no zeros?
Yeah.
It's possible. You know, if I expand this all out, it's possible to not have any zeros. Quadratic formula says that I can have some imaginary numbers in there, right? Okay, so when I go through and start factoring, okay, but in this case I am going to. Okay, so if you end up with whatever, it's possible to have no zeros, 1 0, 2 0, or 3 0. Okay, so we could have a function that looks like this. I totally missed that one right there. Okay, so we could actually have a 0 here and just a touch 0 there without crossing the axis, right? So that would be 2 zeros. Does that make sense?
Yeah.
So I have shown right here that it's going to be somewhere in between there and there. I tested the endpoints. So if both of them are negative, would the intermediate value theorem work here? No, right? Okay, so now let's go back to the chicken crossing the road. So if the chicken starts on the left-hand side of the road and he's ending on the left-hand side of the road, can you prove that he eventually crossed the road?
No.
No? No, you're just smart. Just stayed on that side of the road, right? Okay. All right, so this one right here is for your calculator. Now, take out that calculator and let's see where it's going to be.
Oh, wait.
All right, let's see. X cubed, x squared. All right, so I'm going to, right here, x cubed, what's up, minus x squared
Yo.
No, plus x squared.
plus x squared
Yes. Yes.
minus x
Minus 2.
minus 2, there we go. And what's the only thing that matters in here?
The x between 1 and 2.
1 and 2. So I could actually, let's change the window. Let's change the window settings. So let's go from, if it's from 1 to 2, let's go from 0. Just so I could actually have a clear view. And let's go to 3. And let's change this. Negative 2. And go to positive 3. Okay. So I changed it. It's somewhere in here, right? Hey, look, there it is. Yes? Okay. So I know that it's going to be somewhere in between there. So we can go through and actually start figuring it out. Okay. So we can see where that would be. So I'm going to go over here and vars function. And so if it's between 1 and 2, let's go 0.5. Is that enough? No? Okay, it's still low, right? Because if we did the f of 1, right? F of 1 gives me negative 1. Okay, 0.5 is negative 2. Okay, let's go 0.7. Sorry. 0.7. Uh-oh. Oh, wait. I'm on the wrong side. It should be 1 point. It's 1 and 2. Dang it. Okay. I was messing up there. I'm messing up. All right. Okay, so 1.5. Okay, still too much. Okay. 1.2. Close. All right, and it said to how many? 3?
It's in between those two.
1 point should be 2 something.
2, 1, something.
2, 1. It's positive now.
Yeah.
Okay, so let's see. Keep going. So here, 1.2. Dang it. 1.205. It's negative. Close. I'm almost to my third digit here. 1.208. Positive. 1.207. Positive again. 1.208. Ah. 206. Still positive. Okay, so now it's going to be 5 is my third number. So it's in between 5 and 6. Right? You guys see that's where it's changing from positive to negative? So I'm going to go 5. Okay, so it's going to be 1.205.
It's negative.
Okay.
Oh no.
One point 205.6.
Positive.
There we go. So it's going to be in between there. So I have 4 decimals here, so I know that I would have for this. Okay, AP test is how many decimal places? Say 3. Okay, so if it's 3 decimal places, so let's look at our notes. Corrected 3 decimal places. So I looked at my second number, right? It's going to be in between 5.5 and 5.6, right? But both those answers right there are going to round up to what if I'm doing to 3 decimal places?
206.
So it's going to be 1.206. 1.206. Okay, because both those 5 is going to round up and the 6 is going to round up because it's in between there. So for this one, it's going to be 1.206. Okay. All right. Okay. Not bad. You guys okay? Okay. Easy stuff with the calculator?
Yeah.
All right. So I'm going to leave off today. Don't forget, like and subscribe, right?